So this is one of my old exam questions that I came up with myself for my Calculus 2 class. And if you want to get more of my practice quizzes and tests for my calculus classes, make sure you join my Patreon because I'll be uploading more material over there. The link will be in the description. For this one, we are going to find out which of the infinite series diverges because of the test for divergence. In fact, I will tell you, 3 of these right here diverge, but only one of them diverges because of the test for divergence, and you have to pick that one. So you know the deal. Please pause the video and try this first before you watch the solution. Done? Okay, first let's review the test for divergence real quick. Right here, all we have to check is the following. If the limit as n going to infinity of an, we just have to work this out. And if this limit is not equal to 0, then we get to draw a conclusion that the series, let's say n goes from 1 to infinity of an, this series diverges. However, make sure you remember that if the limit does give you 0, then we cannot conclude that the series converges. An example is the series of 1 over n. But for this one though, all we have to do is to take the limit as n going to infinity of this, and that, and see which one is not equal to 0. Then we'll be done. So here we go. For the first one, we take the limit as n going to infinity of ln of n over n plus 1. Do this inside out because ln is a continuous function. So if you look at the inside, we have n over n. You can ignore the plus 1 because n is going to infinity. N over n is just 1. ln 1 is 0. So this limit actually gives you 0. Unfortunately, when we're trying to do the test for divergence, this 0 is inconclusive. Now, do the next one though, later. Do this one though, if we take the limit as n going to infinity of n over n squared plus 1. This time we still look at the n, but here we have n squared. Still ignore the plus 1. This is like 1 over n after we reduce the n. As n going to infinity, we get 1 over infinity, which will give us 0. Again 0. Inconclusive. Again, for d, if we take the limit as n going to infinity of n over n cubed plus 1, look at n and n cubed. That's the same as 1 over n squared. As n going to infinity, 1 over infinity, still 0. So, in fact, test for divergence does not work for this, and that, so it must work for b. It does work for b. Anyways, that's why I'm doing this the last. If you take the limit as n going to infinity, as n going to infinity of n over n plus 1, n over n, ignoring the plus 1, here you get 1. And the 1 is great because it's not equal to 0. So we get to say that this series diverges because of test for divergence. And that is the answer right here. Now, you might be wondering, how can we show that if the rest diverge or converge? Well, I will tell you this real quick. For the first one, I'm just going to put it down right here. We can use the log property. You can look at this as the series as n going from 1 to infinity of ln of n minus ln of n plus 1. Now, as you can see, we have a subtraction in between. This and that are of the same kind, right? Both of them are ln. And the input, they are just off by 1. This is n, this is n plus 1. So this right here is an example of a telescoping series. So make sure you know how to continue from here once you notice this is a telescoping series. Now for the next one right here, if you look at the series and if you just ignore the plus 1, then you can see the series is very close to what? 1 over n. So you do a comparison. Right here you can compare it with, you can try to do it with the limit or the direct comparison test. I will tell you the direct comparison test is not that good in this case because the inequality is not going to work out so well. So for this one right here though, this is for A. For C, I will tell you, go ahead and use limit comparison test with the series as n going from 1 to infinity of 1 over n. It's much better to do the limit for this one, right? You can try with a direct comparison and you will see that it's really not going to work out of the inequality. For the last one, same thing, n over n cubed. Reduce the n, we get 1 over n squared. That is just a convergent P series. And in fact, the direct comparison test works out very nicely because you can show this is less than the convergent series, 1 over n squared. So for D, direct comparison test. Or in fact, if you just want to do a limit comparison test, that also works for that as well. But for this, you do it with the series of 1 over n squared. And make sure you know how to write out the rest of the details. Yeah? And if you need any help, leave a comment down below, let me know. I'll be happy to explain all this in detail for you guys.